Hi guys, welcome to my channel. Today's video is on the topic section formula. So using this formula we can calculate the coordinates of any point which is dividing a given line segment in a particular ratio. So here we have line segment AB with coordinates x1 y1 and x2 y2 respectively. Point C is dividing it in the ratio m1 is to m2. So let us say the coordinates of C are x, y. So the easy way to remember this formula is when you want to find the x coordinate of this point C, we cross multiply it. So we multiply m1 with the x coordinate of B plus m2 with the x coordinate of A. So therefore x is equal to m1 x2 plus m2 x1 upon m1 plus m2. Similarly we do the same for y. So y is equal to m1 y2 plus m2 y1 upon m1 plus m2. So this is the section formula. So let's now solve some questions based on the given formula. Now in our first question we have been given AB, a line segment, and P is dividing this segment in the ratio 2:1. So let's begin by drawing the diagram. So if we use the section formula, we'll have x is equal to 2 into 1 plus 1 into minus 2 upon 2 plus 1. So if we solve that further, that gives us x is equal to 0. Similarly for y, we'll get 2 into 4 plus 1 into 1 upon 2 plus 1. So that gives the value of y as 3. So therefore the coordinates of point P is 0, 3. In the next question, they have given us the coordinates of center of a circle. Now since AB is the diameter, hence points A and B both would be lying on the boundary of the circle. So we know that AC and CB are both radius, so they both will be equal. So since they are equal, their ratio will be 1:1. So that is AC is equal to CB is equal to 1:1. If we assume the coordinates of B to be x, y, then by section formula we'll get, now since C is dividing the segment, so the coordinates of C, which is -2, so -2 is equal to 1 into x plus 1 into 3 upon 1 plus 1. So that gives us the value of x as -7. Similarly, 5 would be equal to 1 into y plus 1 into -7 upon 1 plus 1. So that gives us the value of y as 17. So therefore the coordinates of B are -7, 17. Now to find the radius AC, we'll have to use the distance formula. This formula I have discussed in one of my earlier videos. You can check that out. So AC is equal to square root of -2 minus 3 the whole square plus 5 minus -7 the whole square. So that gives us 20 square root of 25 plus 144. So therefore the radius is 13 units. Now our next question is a bit different. So here they have given us the coordinates of the point which is dividing the line segment, and we need to find the ratio in which it is dividing. So till now they were giving us the ratio and asking us to find the coordinates of the point. So in this question they are asking us the exact opposite. Now in all such questions where the ratio is to be calculated, we'll always assume one of the part of the ratio to be 1. So let's say the ratio is m:1. So now why do we do this is because if we assume one part of the ratio to be 1, so that leaves us only one unknown variable to be calculated, which in this case is m. If we don't do it this way, and if we assume the ratio to be m:n, then we have to find two unknowns. So now 5 would be equal to 7m plus 2 upon m plus 1. So by cross multiplying we'll have 5m plus 5 is equal to 7m plus 2. So after rearranging the terms, we are left with m is equal to 3/2. So the ratio will be 3/2:1. So in order to not have a fraction, we'll multiply both sides of the ratio by 2. So that will give us 3/2 into 2 is to 1 into 2. So that gives the ratio as 3:2. In this question, they have given us the coordinates of point A and B. We need to find in what ratio will the x-axis divide this given segment. And then also they are asking us to find the point of intersection of the x-axis and the given segment. So let's first begin by drawing the x and y-axis. Now since point A is given as -4, 3, so since the x coordinate is negative and y coordinate is positive, so our point A will lie somewhere in the second quadrant. Similarly, point B is 8, -6. So now the x coordinate is positive but the y coordinate is negative. So point B would lie in the fourth quadrant. So let the segment AB intersect the x-axis at point C. So since point C will lie on the x-axis, so therefore its y-coordinate will have to be 0. So therefore let point C be equal to x comma 0. Now again let's assume the ratio as m is to 1. So AC is to CB is equal to m is to 1. Now by applying the section formula, let's start with the y-coordinate of point C. Since it is given as 0, it will be easier to solve that first. So the y-coordinate of C is equal to 0. So 0 is equal to minus 6 into m plus 3 into 1 upon m plus 1. So by cross multiplying, again because we have 0, the whole part will become 0. So minus 6m plus 3 will be 0. So that gives us m is equal to half. So our ratio again will be half is to 1, and like our previous question, we'll multiply both sides by 2. So that will give us 1 is to 2. Now for finding the point of intersection, we need to find the coordinates of point C. So only coordinate x is what we need to find now. So now our new ratio after multiplying was 1 is to 2. So that gives the value of m as 2. So again using section formula, now x will be equal to 8 into m plus minus 4 into 1 upon m plus 1. So if we put the value of m is equal to 2, we'll have x will be 16 minus 4 upon 3, which gives us the value of x as 4. So hence our point of intersection is C 4, 0. In our last question, now let's see if we can prove whether three given points are collinear or not using section formula. So let's first begin by assuming that the points are collinear. So what does it mean by being collinear is that the given points will lie in a straight line, that is a single line. So let's say P is 3, minus 2, Q is 5, 2 and R is 8, 8. So using section formula, we'll have phi is equal to 8m plus 3 upon m plus 1. So solving further, we have m is 2 upon 3. Similarly for the y coordinate, we'll have 2 is equal to 8m minus 2 upon m plus 1. So again we have the value of m as 2 upon 3 only. So since value of m is equal for in both the cases, that means that point Q is dividing this segment in a particular ratio. So any point can divide a particular segment only if it is lying on that segment. So this shows that Q lies on the segment PR, and hence the 3 points are collinear. So that's all I have for you today guys. Hope this video was helpful. Thank you for watching.